All right, now let's take a minute and make some conclusions about what we know about taking an exponential function and making it linear. All right, number one, if we graph it and x log of y is linear, then we know that x comma y, or the original one, is exponential. So we left the x values the same. All of the y values we put a log in front of. If that produces a linear equation, when we work backwards, we know the original one was exponential. Okay, if the graph of xy is exponential and we're able to say that, then if we graph all of the x values, take all of your y values, put a log in front of them, then we know that graph is going to be linear. Now, once we have made our data linear, we can use the least squares regression on the transformed data x log of y to find the best fitting linear model. So we are going to find the linear model based on what graph makes it linear. So x log of y, that's what we're going to do the exponential regression on. So what you're going to do is set up your list in your graphing calculator. Okay, so number one, you're going to put your x into list 1 and your y into list 2. So basically you'll have x comma y. This is going to be list 1. This is going to be list 2. Okay, now then what you're going to do is in list 3, you are going to take the log of list 1, which is going to basically take the log of all of your x values. And we'll talk about why you're going to do that in a minute. So basically you're going to go to list 3 at the top of it. You're going to type in log of list 1. You're going to put that into list 3. And that's basically going to take all of your x values and put the log in front of them. Now, to take the y, what you're going to do is go over to list 4. Okay, at the top of it, you're going to highlight it. You're going to write log and then list 2. And basically that will take all of your y values and take the log of them. So now you're going to have x comma y. This is going to be list 1 and this is list 4, because this will be the log of all your y values, which made it linear. And that is what you're going to do the linear regression on. Now, I will explain this again on the calculator in a second. So if you're confused by this, hold on. Now, just be careful here. The log of 0 is undefined, okay? So if you have, let's say in your x and your y, you have 1, 2, 0. So that's list 1, that's list 2. Then in list 3, when you take the log of x, or list 1, and in list 4, when you take the log of y, or list 2, you are going to end up getting something that says error, domain error. The reason for that is we cannot take the log of 0, so it will not give you an answer here. So you would have to delete this entire row. Even though the 2 is okay, you have to delete it, because if not, you're going to get an invalid dimension error, which is going to mean your lists are not the same length. Okay. All right. So let's see what this looks like. So based on the same data set that we're taking a look at, we have X is our time in months, Y is our account balance. We're going to transform the original data by taking the log of Y. Okay. So remember, our original was XY, that was exponential. So to make it linear, we're going to now graph X. All the X values will stay the same. Basically what we're doing is we're taking all of these Y values and we're taking the log of them. Okay, and we're going to get a new set of y values to graph. But don't worry, your calculator does all of this for you. Okay, so our original graph and equation was xy. Our new one is x. Now the y values are just log of each of them. Okay, now if you did an exponential regression, okay, because we knew it was an exponential function, this is what it would have looked like. 99.9 times 1.01 to the x, exponential because x is here. Okay, so that would be, if I was going to graph the exponential regression, this would be your equation right here. Okay, now what you're going to do is you're going to graph your new graph and your new equation. So remember, this was list 1 and this was list 3. So you need to change your y to list 3 because that's where you've taken the log of all of your values. Okay, so when you do that, remember, turn your plot on. We want our first one. Your X list is list 1 because we did not change our X values. We still had these in list 1. But when we took the log of list 2, we put that into list 3. Okay, so then we have to say get our Y values. No longer we're not getting them from list 2, but we're getting them from list 3. Now you go to graph. Okay, remember you're going to go to second stat plot. Okay, and then just hit the graph button. Okay, which is right here. Hit your graph. If it doesn't come up, notice, remember, you go zoom 9, and then notice how beautifully linear that now is. Okay, now I have a linear equation. Now to get the actual equation, what you're going to do is you're going to hit stat. You're going to go over to calculate. You can, there's 2 linear regressions on there. It doesn't matter which one you use, but just make sure that you say X is list 1 and Y is list 3. So try this on your calculator to make sure you can do it. Now notice our A is our y-intercept. Here's our B value, that's our slope, and look at our R squared and our R value. That's pretty good, okay? So that's about 1, which is about as good as you get for a linear equation. Okay, now the new graph and the new equation came from X log of Y. Now the question here is, how do I write this? So remember, we always write our equation as y hat equals your y-intercept plus your slope times x. Now, when you rewrite this, we did X log of Y. So if I was going to rewrite that equation, you would say, hey, y equals ax plus b. So I would just write it as y equals, okay, my slope right here, or sorry, just make sure you're writing this correctly. Okay, so my, this is in the form y equals ax plus b. So my slope is 0.004. Okay, because the a is in front of the x, so the a is my slope, and there's my y-intercept plus 1.99. Now, this is not correct. Even if you put the y hat here, this is not correct, okay? The reason is because the new graph and equation came from X log of Y. It was not just the Y values. I took the log of all the Y values in order to get it exponential. So, or sorry, in order to get it linear. So you must put the log in front of the Y here, okay? And it's easy, just look at your transformation and then put the log was in front of the y, so the log has to go in front of the y here, okay? So log of y hat equals 2 plus 0.0043x. Did not have to change my x because my x was not changed here. Now notice here, this, okay, we want to put this in context. I don't want to necessarily write it out every time. I don't want to write like y hat equals, so I'm just going to write the log of the predicted account balance is equal to 2 plus 0.0043. My x was time, okay? Now, you have to include the log in front of the y because this is what made it linear. Now, it says, what is the predicted account balance after 100 months? So this is saying, hey, I need to put 100 in for time or my x. All right, so let's see what that looks like. So I insert 100 in for x. Okay, that whole side right there, I'm just going to type it into my calculator exactly how we see it. Now, there's 2 ways to do this. Number 1, this says the log of y hat equals 2.431. We're not done there because y is not solved. I still have a log in front of it. So in order to solve this, you have 2 different ways to do this. I think the easiest is to rewrite this as an exponent, which I'm going to show you how to do over here. Remember, log has an understood base of 10. Y hat equals 2.431. Now remember, to rewrite this as an exponent, the base of the log becomes the base of an exponent raised to the 2.431 equals y hat. Okay, equals what's after equal sign right here. So then all you need to do is type this side into your calculator and you're complete. Okay, now the other way that you could do this, I think it's a little bit harder, but you could raise both sides to the 10 because what happens here is your 10 is going to cancel out with your base because these have the same base. Remember, when they cancel each other out, you're just left with right here. And then you can just plug into your calculator 10 to the 2.431. Okay, the 10 and the log cancel each other out. I personally like to use this method, but you do whatever works for you. Okay, all right, so now for your reverse transformation. Now, please keep in mind, like your calculator can do this for you. You know that x log of y made it linear, therefore x comma y was exponential. So this was an exponential equation. So in order to get the exponential equation, all you have to do is perform on your calculator an exponential regression, the same place you got linear regression, only you're going to do an exponential regression, and you're going to do it on list 1 and list 2 because x and y were list 1 and list 2, and we knew they were exponential. Okay. All right. So let's just say that this was our equation. We could reverse it by hand, which is kind of a pain, but we can do it. And this is what it looks like. You do not necessarily have to know how to do this, but we want to get rid of this log of y hat, or we want to get rid of the log in front of the y. So remember, if I raise both sides to the 10 and the base of 10 here cancel out, and I'm just left with y hat. Okay, so now I have 10. Everything here is in my exponent. So what I did here, this is your property of a log, and same thing with the property of an exponent. If these two pieces are added, remember we can multiply them. So 10 squared times 10 to the 0.0043x, because remember bases are the same, you can add the exponents. Okay, so I 10 squared, I simplify it, and then all I did here was a property of an exponent is I popped that x out front here, or sorry, to the side, because remember when you have a base raised to a power, you would multiply the exponents. Okay, so then it just made my life a little bit easier because I took this right here, plugged it into my calculator, and got 1.01. This is your exponential model. Now notice this just has my y hat here. I don't have the log. The reason I don't have the log is because I did not have to take the log to get the exponential function. Also, the much easier way is literally to plug this in your graphing calculator and then just write y hat equals 100 times 10, and it will give you all this to the 0.0043x. Okay, it will give you that answer, or actually it'll give you the 1.01. So it'll give you 100 times 1.01 to the x. Okay, but remember that's list 1 and list 2 because that was before you transformed it. Okay, all right, now the next thing we're going to take a look at is power functions. So I'm going to stop the video now and you guys look at the next video for your power function.